So we are solving LeetCode question 344, reverse string. Write a function that reverses a string. The input string is given as an array of characters S. We must do this by modifying the input array in place with O of 1 extra memory. So basically we are not going to use any data structure and we are going to do it in place. So we are given an array S with letters HELL, hello. We are going to reverse the string. To do this, we are going to use the two pointer approach. So first of all, we are going to point at the first element. That will be our left pointer, and we also set a pointer to the last element. So the first element will point to index 0 and the last element will point to the last element. The length of S minus 1. Okay, so now whenever we see two characters, so let's go and scribble. If we take S, now S equals H E L L O, comma, 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 comma. What we want to do is we are going to modify it in place. So 1, 2, 3, 4, 5. So we are going to modify it. 1, 2, 3, 4, 5. We are going to modify it in place. So first of all, what we want to do is we want to reverse it so that it becomes O L L E H. So when you take O and L, we have to swap them. L and E, we have to swap them, and we have to basically swap L with itself, or we just leave L like that. So if you have this, we can first say, okay, pointer left pointer is pointing here, and right pointer, the left pointer is pointing to H and the right pointer is pointing here. So let's start here. When left and right are here, we just want to interchange it. So we put the element here, we put it here, and the element here, we put it here. Then we increase the left pointer by 1. Then we decrease the right pointer. We decrease the right pointer. We decrease the right pointer by 1. We bring it here. We do the same thing. L and E, we bring the L here, we bring the E here. Right? And now we move the left pointer here, we decrease the right pointer to here. So there are two conditions here. When the two numbers are not even, that means you're going to reach one number, and that number will still be in the middle. But if the two numbers are even, let's say B, A, B, A, then basically what you're going to get is we just bring the A first, then we bring this B here, then we bring this B here, then we bring this A here, and at this point, so we can use two methods, while left is less than right, or while left is less than equal to right, and both are going to work. So let's code up the solutions. So we are going to say while left is less than or equal to right, we're going to say we're going to interchange them. The number at right, this is Python's way of performing substitutions. We're going to interchange them. Okay. Then we're going to decrease the right by 1 and increment the left pointer by 1. And because we are doing this in place, we don't have to return anything. So when we run this, okay, So we are encountering a problem. It says we spelled right wrong. So R-I-G-H-T. Okay, so you submit and it is accepted. So this algorithm runs in O of n time complexity, and it has a constant space of O of 1. If you don't want to do it this way, you can just use while left is less than right, and the algorithm will still run. So let's run this and see. Yeah, the algorithm still runs, and the reason is because when we have a number, an array like this. This one is odd, HELLO. It is odd. So when the 2 pointers are moving together, at some point both of them are going to point at the same number in the middle. But if you have an array that is even, that has even elements, as I gave it here, BA, then at some point the array that is on the right is going to cross over here, and the array that is on the left is going to cross over the array on the right, and those two pointers and the while loop will break. So while left is less than right, at that point left will be greater than right. But if so for this situation, when left is less than right, left will be greater than right, and right will be less than left, or left and right will be equal. But for this particular algorithm, when left and right are equal, we just leave that element here, as in L. We move from H and O to E and L. The moment we reach L, L is in the middle. L and R are equal. Both pointers are equal. We don't interchange anything. We just leave it. We just exit, and that's it. Or for the second algorithm, we've moved from H and O to E and L, then we move from R and L, both of them point, then we basically interchange L with itself and put it inside. So basically we are going to do more work when the array is an odd number of elements. So this algorithm also works, and it has O of 1. It has a time complexity of O of 1 and space complexity of time complexity of O of n and space complexity of O of 1.